Okay, I'm going to go through the answers to these stopping distance questions for you now. Okay, so question 1, the stopping distance of a car depends on the thinking distance and the braking distance. Thinking distance depends on the driver's reaction time. You have 2 factors that can affect the reaction time. There are actually 4 factors you could put. So alcohol, drugs, tiredness, or you can write some sort of distraction. So you might have put mobile phone, you might have said texting, you might have said someone talking to you and turning around, or something like that. So that's out of 2. Okay, so any 2 of those. Give 1 factor that can affect braking distance. These are things that affect the car. So only 1 mark available, so you could have speed. You can have the condition of either the brakes, the tyres, or the road. So one of those, okay? You can have also, if there is water, ice or snow on the road, okay, so one of those. Or you can also have the braking force. So some brakes are better than others. Then it says the thinking distance is the distance travelled during the driver's reaction time. So a car was travelling at 13 metres per second. So that's the speed. And the driver's reaction time was 0.6 seconds. That's our time. The question says calculate the thinking distance, and it gives you this equation here. So you're just going to plug the numbers in. Distance is speed times time. So the speed is 13 times your time, which is 0.6. And then your answer there should be 7.8 metres. Okay? 2 marks. 1 for this, 1 for this. Then it says the braking distance of the car was 14 metres. What was the stopping distance? So stopping distance is equal to the thinking distance plus the braking distance. So you're just going to add the 2 numbers together. So our thinking distance was 7.8, and in the question our braking distance was 14. So 7.8 plus 14.0 is 21.8 metres for 1 mark. And then next question, E. What is the link between speed and braking distance? Complete the sentence. The greater the speed, the greater the braking distance. So if you've put a word that means greater, like bigger, or the braking distance increases, that's fine. 1 mark. If a large braking force is applied, the car decelerates and stops in a short distance. Give 2 disadvantages. You can have the brakes overheat or are damaged. Or you can have the car goes out of control or it skids. Or you can have refer to some sort of damage either to the car or the occupants. Like braking too hard could give you whiplash, for instance. Okay, 2 marks. Okay, this one and this one. So any of these 3 for this mark and any of these 2 for those. That one. Okay, what I want you to do is, if you're only doing foundation, although I would say give higher a try as well because you will get some marks, in the comment section please put your mark out of 9. Okay, higher. Figure 1 shows the distance time graph for a car travelling at 15 metres per second. And then this question says, when the driver is tired, the reaction time increases from 0.5 seconds to 0.82 seconds. Determine the extra distance. So on the graph we need to get what is the distance at 0.5 seconds and what is the distance at 0.82 seconds. You need to carefully draw your lines on, especially with the second one because it's not quite on the line. So 0.5 seconds is here, which is actually at 7.5. And 0.82 is actually midway through a square. So it's about here, which is 12.3 seconds, okay? So your answer you're looking for here is 7.5 and 12.3. So you're looking for the distance between those two. So the extra distance will be 12.3 minus 7.5, which equals 4.8. So 4.8 meters for that. Okay. The mark scheme, let me just check if the mark scheme allows you. Yeah, so the mark scheme says you can have between 12.2 and 12.4 for this, which then means, so any of those numbers, so any distance between 4.7 to 4.9 scores both marks. So you get a mark for getting your values off the graph and then a mark for the answer. Okay? Next, when the brakes are used, the temperature of the brakes increases. Explain why. So this is going right back to the start of energy and our P1 topic. So what happens is the kinetic energy of the car decreases. That's because it's going slower. So that energy needs to go somewhere. So what it does is it increases the thermal store of the brakes. So the brakes get hot. Okay? Then it says a lorry travels 84 metres with a constant acceleration of 2 metres per second squared to reach a velocity of 19 metres per second. Calculate the initial velocity of the lorry. Use the physics equation sheet. So the physics equation sheet is a sheet you get in the exam, and it gives you this equation which we've been working on. Now we're actually going to find something different in this question than before, but the principles are the same. Just put the numbers in and then work out what you're missing. So let's write V, U, A and S here and read the question again. So the lorry travels 84 metres, so that's our displacement, so that's S, with a constant acceleration of 2, so that's our A, to reach a velocity of 90 metres per second. So it's reaching that velocity, so that's our final velocity. So let's put those numbers in there. And then our U is what we want to find. So we're going to substitute now these numbers into here. So V squared, so 19 squared equals U squared, we don't know U, plus, I'm going to pop this in brackets, 2AS, so 2 times A, which is 2, times S, which is 84. And you get 1 mark for writing that out. The next mark is for actually doing a bit of calculation. So 19 squared is 361. Okay, and that will equal U squared, and then you've got this calculation here. So 2 times 2 times 84 is 336. Now, we need to get rid of this plus 336. We take it to the other side and it becomes take away. So we've got 361 take away 336 equals U squared. Okay? You get a mark for doing this. That becomes 25 equals U squared. We now need to get rid of the squared, so we do the square root of 25 equals U. And that gives us an answer of 5. Okay? And that last 5 is what the third mark is for. So you have here, if you've done foundation, you should have proper marking here out of 9, and then if you've done higher as well, out of 16. And then in the comment section on the classroom, I need you to put that mark and whether it's out of 9 or 16 so I can check what you got. Thank you very much.